So in this case, we are going to consider as a continuation, moving from what we had previously, the basic view of our line shafts. Now we are going to look into the calculations. What is important to consider when you are dealing or when you are working with the line shafts. As I said before in our introduction, that line shafts are rotating members driven by what? Which are driven by a motor. So, meaning to say, on our calculations, the motor is to be considered as it has properties which are affecting the line shaft, and also that a line shaft rotates due to an applied tangential force for it to rotate. It rotates due to applied tangential force. As a result, the motor usually generates the tangential force because it rotates due to that, and the motor is the one that is supplying. So as a result, that is what you have. The shaft rotates at the speed of the motor. The shaft, which is our line shaft, it will rotate at the speed of what? Of the motor and transmit power. Remember, it's driven by the motor. So as you can see, we are talking about what? Rotation. There must be speed, revs per minute. There must be torque to be calculated. So these will be the calculations now on based on what we are dealing with. The motor, the line shaft, and also we also have the belt drives. All right, where we consider the belt drives, you're gonna have the pulley system. So the pulley system will be having what? Will be having the belts. So you consider those belt drive calculations, like I said before. All right. So without wasting your time, let us consider the first one, which will be based on the torque that is can be calculated, but torque depends on what exactly is being where exactly it is being transmitted. Is it transmitted by what? The torque depends. It is transmitted by what? So we've got the torque that is being transmitted. The first one by the shaft. All right, by the what? By the shaft. So if we consider, all right, so we do understand torque is represented by the letter T and is measured in Newton meters. In that case, our torque from our basic formula, force times what? The perpendicular distance, which is the radius. All right, so this is gonna give us our torque in what? In Newton meters. So our force in what? In newtons, and this is our perpendicular distance, which is the radius that is taken in what? In meters. All right, or we can have this one still as the torque transmitted by the shaft. We can have it as pi over 16 d cubed times tau. All right, so there we are still calculating the torque in what? In Newton meters. So the D is the shaft diameter as we are considering the torque transmitted by the what? The shaft. It is transmitted by the shaft. So it means the diameter that you are considering is the diameter of what? The shaft. So this is the shaft diameter. Just like here, the radius is the radius of the shaft. So that's our shaft diameter in what? In meters. Then the tau that we see there, it represents the shearing stress. This is our shearing stress. All right. So the shearing stress measured or taken in what? In pascals. So that's it. We have got the second formula, which is for the torque that is transmitted, but still it is transmitted by what? By the shaft, because we can have the torque that is transmitted by the what? By the belt from the belt drives. All right. So you dealt with torque before from your belt drives. That's why I told you guys to revise uh, the basics of your belt drives. All right. So we also have to consider that one. Torque transmitted by a belt. So whenever you consider what is transmitted by the belt, this is part of what? Part of the pulley. All right. The pulley is the one that is having what? Those belts. So you're talking about the pulley. All right. So still same consideration. We are talking about the torque, guys, which is T. So, but the calculations now, remember, as you consider the belts, you'll be consider the tension T1, T2. So that is the torque there is calculated from the effective tension, which is T1 minus T2, the effective tension, effective force times what? Times the radius. So we must take note effective tension T1 minus T2. That's our TE, the difference, where T1 is representing the tight side and T2 is the slack side that we have. All right. So that is it, guys. Tight side. All right. This is our slack side. So these are the tensions. All right. These are the tensions that we're talking about here. Tight side tension. Remember tension force in what? In newtons, all right? Then we have got R there representing radius. Remember dealing with the what? The belt. So that is the radius of the pulley. So this here becomes the radius of what? Of pulley. So this is it. You have your torque there in what? In Newton meters, just like before. But you're dealing with the belt now. Belt drives. We are back to the belt drives, all right? Then we've got the power transmission, also to be calculated. Power transmission, all right? So the power transmission, that's basically represented by the letter P. So remember, power, we had power from N4. Power is omega times what? Times T. If you have got calculated the torque here. If you have calculated the torque, remember T, that's your torque there. In Newton meters, you have it. You can simply use omega times what? Times T, where omega is equal to 2 pi n over 60 in what? In rad per second. All right. So that is from the speed in revs per minute, which is the shaft speed. So if we put this here in place of omega, it simply tells us that the power can be written as what? 2 pi n, that's 2 pi n times what? Times the torque over what? Over 60. So that is, you have the power. And remember that power is measured in what? In watts. Can be kilowatts, depending with your conversion at the end of the day. So this is it. Omega being what? The angular velocity. Our angular velocity. Remember those conversions that you used to have before in N4? Angular velocity. We are back to that. And also, remember in our N4, we said we can make whatever that you want here the subject of the formula. So that's T can be calculated. The torque from here, if you make the subject cross multiply, T is going to be 60 P over what? You're going to divide by 2 pi n over 2 pi n. That's it. We've got the torque there in what? In Newton meters. Can be calculated from there. Speed can also be calculated. If you have the torque, you've got the power, the speed. Can make the speed the subject, still multiply there. So it's going to be 60p over what? 2 pi t. You divide by what? 2 pi t. So that's it. The speed can be made the subject of the formula in what? In revs per minute. So it can be determined. So there's nothing that is new. N talked about this, the shaft speed. All right. So everything is there. N, that's our shaft speed. P, that is the power transmission, the power that is transmitted that you have, and T is the torque, as we had this one before. So that's another aspect, very, very important to be considered, which is calculation of what? Of the power. All right, moving on, another part that is also important is the shear stress. So the shear stress from our N4 engineering science, that's tau there, all right? And it is measured in what? In pascals, all right? So tau can be calculated. So the formula basically that you can use here is that tau is equal to 16t over pi d cubed. So you must know this formula, and our tau is measured in what? In pascals. So nothing here, still the same torque as we had before in Newton meters. It is still the shaft diameter that we had before, which is in what? Which is in meters. All right. Then another aspect. All right. From here, we can just make whatever that you want here the subject of the formula, as we have got the shear stress. Therefore, we can just consider, all right, let's make T the subject. If you cross multiply, it's gonna be pi d cubed, all right? So I want to find T. So T will be equal to, this one's they multiply. So it's gonna be pi d cubed times tau over what? So you're gonna be left with 16. It will be 16t. So you're gonna divide by what? By 16. So you can actually make t the subject of the formula. You're talking in what? Newton meters. You can make the diameter of the shaft the subject. Let's say you cross multiply. You were going to divide. So it was gonna be d cubed is equal to 16t over what? Over pi times tau. All right, over pi times tau, like this. So to find d, you're gonna introduce the cube root from our mathematics. So that's d is equal to the cube root of 16t over what? Over pi times our tau, which is our shear stress. So that's it. We can calculate our diameter in what? In meters from that. It is just a matter of playing around with the formula, change of subject, all right? Change of subject of the formula from your literal equations, all right? So this is it. Basics are needed. Shear stress can be determined. Number 6, you can determine calculations which are actually based on reactions. All right, calculating. Let me write this one down. Calculating reactions. Calculating reactions in the what? In the vertical and horizontal. And horizontal planes. So it's an important aspect to be considered. Calculations or made on reactions, which is calculating reactions in vertical and horizontal planes. So whenever you consider the reactions, because what is happening, remember here we are saying the setup that we have, all right, the setup that we have of the line shaft. There is an electric motor. Then we have got the drive pulley. Then here, if we check, we've got the bearing supports. They're supporting the system, supporting the what? The line shaft. So at the end of the day, we are going to notice that this can be used as part of your moments because you'll be having something like this, the bearing on the left. Then maybe you can have, depending with the question that you're given, maybe there are two pulleys that are there. This can be pulley A, then it goes to pulley B, all right? Then to the end, there is a bearing. So these are bearings that you have one and what and two. They will be your supports. So given whatever distance from one to another, we can calculate the reactions. Calculating reactions is calculating the value of what? R1 and R2 as of the bearings 1 and 2. So remember, this is our first bearing and this is our second bearing. So the reactions are on bearings. If you consider this is 1, this is 2, so you are to calculate R1 and R2. This is what it means. But this can be in the vertical or it can be in the horizontal planes. So when we say vertical, we are considering where you are focusing with the vertical loads that are being given. So according to the diagram, or according to what you have, the bearings will be your supports. So just take them as your support so that you do not confuse yourself in calculations. All right. Then whatever that you be given, you consider from the information how it is given, like how the the forces will be given, the tensions, how are they given? Are they going up or are they going down? All right, so that will be the consideration that you must put into, or are they going to the left or to the right, which is what horizontally. So we can have something that is what horizontally given. That is why we are talking about vertical and horizontal. So if they say vertical planes, you must consider for maybe A and B both are vertically, or one of these is vertically given. All right. So if it is given like this, going down, or maybe it is going up, this is the vertical. Going down or up horizontally, this manner, this is horizontal. So meaning to say you check which one of the two is in the horizontal, which one is in the what? In the vertical. You work with the one that you are given there. All right. If both are in the vertical, then use them both in the vertical, depending with the information. All right. So this is basically when you've got a pulley and another pulley, then there are two bearings as part of your supports. So as we can see here, it is just use of what? Moments. In order for you to calculate those reactions, there will be use of what? Use of moments. Use what? Moments. You can use moments. Remember, from your moments, sum of anti-clockwise moments is equal to sum of what? Clockwise moments. You can use sum of forces. All right? Use forces. Sum of forces, because as we consider forces, we have got, if it is vertical, if they take it in that statement to say it is vertical, you're simply saying what is going up must be equal to what is going down. If they say horizontally, you have a diagram like this, but you just assume that this is your presentation, but you'll be knowing that R1 and R2 are horizontal. It is the same thing horizontally. What is going to the right must be equal to what is going to the what? To the left. So this is the idea when you deal with forces. You can consider vertically to say what is going up, sum of what is going up must be equal to the sum of what is what? Sum of what is going down in terms of the forces. So actually going up or down, this is what? Vertical. All right. Then when it is to the right or to the left, that one will be horizontal. So we can have the horizontal when we consider what is going to the left, the sum of forces must be equal to the sum of forces to the what? To the right. So this idea actually can help you to find these reactions R1 and R2. We're going to talk about this in calculations. You'll see very easy as long you understand your moments from your engineering science N3. Revise those N3 videos. N3 as it is, you see that it's just basics that you have. Remember, when you deal with this condition, on this presentation here, you are viewing R1 and R2 as your supports. So for supports, for us to have a uniform presentation, we are going to use R1 and R2. R1 on the left, R2 on the right. Then for the loads, can be anything. You just write what is the load that is given. And that condition, is it going up or down? All right, when I'm saying is it going up or down, this is what I'm trying to say here. We can have A and B as two pulleys, like I said. But these two pulleys, A and B, are given in this manner. All right, so let's say A is having something like this. This is pulley A. Then we have got the one for what? For B. Then B is maybe going up, or it can be going down, but it is facing up or down, which is vertical. So let's say this is for B and this is for A. B as a pulley, it has tensions, which will be T1, T2. These are the tensions for what? The tight side and the slack side. But as you consider that we are dealing with the B, we can just write TB1 for this one, TB1 or T1B, depends what you want, TB2. So this is the tight side and this is the slack side of what? Of B. So this is what you have. These two, A and B, TA, these are pulley tensions. They are tensions of what? Pulley B. Tight, slack. A will be also having the same, just like B. Its tensions, the tight and what? And the slack. Maybe this is your T1, this is your T2. So it means that it's for A, so it's going to be TA1, the tight side, TA2, the slack side. So these will be tensions of what? Of pulley A. This is the idea. Tensions of what? Of pulley A. So these tensions, now you must be very careful because remember we are saying what you have there is can be horizontal. So if you see this presentation, this is horizontal, this horizontal. So it can be facing right or can be facing left. Then this vertical going up or going down. So meaning to say, according to this presentation, according to my illustration here, A, pulley A will be used You use pulley A, this idea for pulley A, you use it whenever you are calculating reactions in a vertical plane. So A is used in what? Vertical planes. Like when you consider a vertical plane, because the one that is going up, vertically up or down. So B, guys, what am I doing here? What am I doing here? I'm talking about B here. Look, I'm talking about this one. B, the pulley, B, vertical up. A, horizontal, this one. A, in what? Horizontal. So please take note, correct that one. Horizontal. So whenever you consider uh, reactions in horizontal, all right, just check which one is horizontally given. It is A. Which one is vertically given? It is B. According to your diagram, you see, according to the information that you're given. So when they say vertical and it is B which is in the vertical, it means on your diagram here, you ignore A. You ignore it. Work with the B. Unless A is also something given on it which is vertically. Maybe it is the weight, whatever that you, unless it has, please do not confuse yourself there. Unless it has a load which is what? Vertically given. That's where you can use it. But if it is only horizontal like this, you use B, which is vertical. The same if they are talking about the horizontal, it means A is the one that is to be used because it has horizontal properties. B cannot be used unless it has something horizontally given from it. That is the idea. So these tensions are the ones that we put together to say, all right, for B, what will be the tension? Let's say TB. You simply add TB1 plus TB2 as part of your tensions. All right. If it is A, you add them together, you combine them together, meaning to say this will be the sum of the horizontal, the sum of the vertical. But in whatever case, whether it is horizontal, whether it is vertical, when you are calculating, bring your diagram here like this. Whether A is horizontal, bring that tension for A in that manner and bring that one for B. So this will be our TA and this will be our TB. The sum of A, the sum of B. On the diagram, this is what you do. Do not worry about say it is horizontal or vertical, but you must be knowing to say this represents what. So if A is horizontally given, so you'll be treating R1, R2 as they are also horizontally given in the opposite direction. If you consider the vertical plane and B is the one that is vertical, it means at that moment you are considering R1, R2 as they are also vertical, but in the opposite direction. So therefore, you can use your moments the way that you understand them because you'll be representing the same thing, but you are just putting it in the way that you understand. All right, so I'm not going to put much information. I was supposed to put an example here. Let me just leave it for now so that I'll explain it much when you've got an example that we'll use into consideration. But it's all about the moments. Then as we have got TA, TB, these are like these are the resultants, like the resultant that you have of the tension. So these are resultant, let's just say resultant belt load from the belts, from the belt drive. All right, from the what? From the belt drive. You take it from the belt drive. And also as part of consideration, the torque transmitted by both pulleys is equal. When you have got this condition, when two pulleys are being joined like that, and another whether it's horizontally, other way or what, these two, they'll be having what? same torque, both pulleys. All right, so both pulleys uh, transmit same what torque. So the torque there is the same. All right, so when tensions are up, like what we saw before, the bearings will be having a downward force, vice versa. You consider what the tensions, if the tensions are going up, like this one is going up, it means the bearings will be experiencing a downward force. If the tensions are horizontally to the right, it means the bearings are horizontally but experiencing a force to the left. In the opposite, it's just a vice versa. So if the tensions now are facing down, like let's say the tensions were facing down, it means the bearings are experiencing what? An upward force. Because the part of the tensions that you have on the pulley are facing down. The bearings force opposes the way that you're given there. That's like a theoretical thing that you must also put into consideration as part of your revisions. Do not worry much. Like I said, we are going to consider a lot, and also shear as part of these. We're gonna see another condition when because some of you might not join the membership, so I was gonna explain this one on membership. When you are given a flywheel, let's say you've got A and B, these were two pulleys, but you can be given a flywheel and a pulley. So when you are given a flywheel and a pulley, this is the condition of a pulley. You go back to the belt drives, the way that you're dealing with your belts. But the flywheel now does not have those conditions. On a flywheel, it does not have belt tensions. All right. On a flywheel, there are no belt tensions here. I'm gonna explain further with examples. No belt what? Tensions. Meaning to say where a flywheel is given, there is no T1, T2 thing. There is that T1, T2. It's when the pulley is considered, you're talking about referring to the belt. So we must consider the tensions. A flywheel, know that that one is not given. There is nothing like that that you're going to consider. The only thing that you consider is the weight. Only weight can be calculated and inertia, but according to what you're dealing with, it is the weight. Remember, weight, it will be a force. So you'll be taking that weight going what? Going down. So the weight will be going down. That's for a what? For a flywheel. All right. So make sure that guys, you become part of the membership so that you do not miss all of the explanations that we are going to have later on, as I shall be explaining on this part with examples later on. All right. So we want to consider the last part. All right, let me just write the last one because here I'm like explaining examples now. All right, someone will be like, what is now explaining examples? Let us just consider also the tension ratio. As you consider the line shaft, there is also tension ratio. Take note, this is a basic view, the line shaft with a pulley, the line shaft where we have got a flywheel. There is going to be another one where gear drives are used. That one, it's all separate. Here we are dealing with just belts. So we shall be referring to the tension ratio, not gear ratio, but what? Tension ratio. And that's T1 over T2. Remember from our belt drives and 4, that's equal to E to the exponent of micro theta, where T1 is our tight side, the one that is the maximum allowable force, and this is the slack side. And we do understand that we have got the coefficient of friction Coefficient of what? Of friction. Coefficient of friction, which is actually just a constant, no units for that one. And we also have theta as the contact angle. So this is our contact angle that we have, which is of the belt. So that's, remember, we're dealing with the belts. So we belt drives, from our belt drives. That's the contact angle of what? Of belt. So from our belt drives, remember we said this contact angle must be in what? In radians. So it must be measured in what? In radians. So for conversions, you can use your N4 understanding that pi is equal to 180 degrees. So whatever conversion that I'm going to have for theta to be converted to radians, I must have theta in degrees. So I must have theta in degrees times, because it's supposed to be theta over 180 times pi. Theta over 180 degrees times what? Times pi. So this is what we have. So it's going to be times what? Pi over 180. So you can use this conversion straightforward. It gives us the theta in what? In radians. This is what? Degrees. Just like that. Or you can just use pi, it's 180 degrees. Any conversion that you want. I do not want to have a lot of conversions so that we do not confuse each other, but you can have any one that you are flexible with. So do revise these basics. In our next class, we are going to look into the calculations now, how to apply the formulas and so on and so on. So make sure that by that time you have the basic view. So this is what we can just have in basics of what we've been having in this class. The formulas from the torque transmission, which is force times radius, the torque transmission by a shaft, which is pi over 16d cubed times tau, which is your shear stress, the torque transmitted by a belt, power transmission, the shear stress, the shaft diameter, the shaft speed. We also have calculations when you consider the moments, those vertical and horizontal plane, sum of forces in the horizontal plane, the tension ratio. So you can see that everything is what is given. So just a basic overview. Go through each and every formula. When you are given a question, try to apply it. Then application of moments, like I said, from your engineering science N3, revise those basics. Please do revise the basics, because we are going to use it in the next classes that you're going to be having.